So what we'll show here in this demo of the really open Lakehouse architecture is really an emphasis there on the open, right? Of being able to have multiple different engines all reading and writing to the same data, in iceberg format, or certainly leveraging Dremio Arctic. So what we'll really go through here is a scenario where we are a retailer, right? And we actually have, a set of tables that we leverage for our business. Let's say for the demo that it's 3, we have the sales fact table, we have the product dimension table, and we have the customer dimension table. So these tables are all populated, but what we actually want to go ahead and do is update them, right? So we actually have daily loads of this data, and the last data that's in there is actually the 28th of February, so we want to go ahead and load yesterday's data for really the whole environment of what we want to load. So what we'll do is really leverage both Spark. We're going to write from Spark and we're going to really read from Sonar, but it certainly could be the opposite if we really wanted it to be, right? We could certainly read from Spark and write from Sonar. We can also leverage Hive, Flink, or any of these other engines if we wanted to, right? So before we jump into kind of the scenario, we can kind of show here that, as Tomer mentioned, that Arctic really has the concept of branches, which will become critical in the capabilities of what we need to do here. So here we can see the branches and tags that exist in the environment. We can see that there's multiple different experiment branches that people are working on in the environment. We also have a couple tags here that tag the entire environment state as of a certain point in time. So we have really the end of quarter for Q3, the end of quarter for Q4, fiscal year 21. So we can leverage these to reproduce the entire environment. So what we'll do here is actually leverage branches via Spark to actually go ahead and update our entire environment atomically, right? Be able to update anything, really all of our environment all at once. So let's go ahead and pull up Spark. So this is actually PySpark running on EMR, right? So what we want to go ahead and do is first is create a branch. So what the statement is going to go ahead and do is create a branch named load yesterday's date in Arctic, which is a catalog in Spark SQL, right, configured to point to Arctic. So we go ahead and execute this, and we see here that we have the name of the branch, and we see the commit hash of what it's pointing to. So now we have this branch created for us to go ahead and do all of our work while it doesn't interfere with any of our downstream, anyone else's reports or dashboards that are running on the tables that we're going to operate on. So what we want to do here now is really, we want to load yesterday's data. So what we'll do here is we'll go ahead and read in this Parquet file in S3 to, this is really the sales data from yesterday, right? So we're going to read that into a data frame in Spark. And as this basically gets read in, what we're then going to want to do with this data that's in Spark is actually write it to the sales table that we saw in Arctic, right? And so you can see arctic.acme.sales, and what you can actually see here is that we're actually referencing this branch name that we just created, right? So we're going to go ahead and write this and append this data to this fact table. And as we write this, keep in mind that as we write this to this branch, right, there's this load yesterday branch that we wrote, that we created, none of our users, as it finishes here, no one else seeing the main branch that all of the dashboards and reports are running on see any of these changes yet, because we're not even sure if they're ready to see these changes, right? Like the quality of this data may not be ready for consumption. And in addition, we don't just want to update sales, we actually also need to update the customer table, right? We need to update both of them at the same time. Otherwise, it's really the single view of the truth within the whole view of the organization starts breaking down, right? So what we want to see here is that we actually are going to have this customer file that's also in S3, it's Parquet file, for yesterday's data. We're going to load that into a data frame here. We're going to go ahead and register it just as a temp table within Spark SQL. Really, this is just creating this alias, this stage customer yesterday alias that we can then use in our Spark SQL statement. And what we want to do here with this customer data, so with the sales table, we just appended the data, right? Because it's a fact table, so it's just additional events. But with customer, which is a dimension table, well, what we actually need to do here is go ahead and actually update the dimension table. So you can see here the SQL that we're going to merge into the customer table at this specific branch, right? We're going to alias that as C. We're going to use this stage customer yesterday and alias that as S, right? Which is kind of the new data. And then we're going to see, okay, what is the really customer ID that it's on, right? And as I go ahead and execute this, it's going to say, okay, if I have an existing record of customer ID that matches one of my new records, go ahead and update street address, city, and state, If I don't and the record's new, go ahead and just insert the record as new, right? So this is truly doing really an update, an upsert of the table. And this is directly, as you can see it finished, this is directly on S3. So this isn't, these are really data warehouse capabilities where you can just do updates as you freely want, right? Update, random, all the fields, we can update more fields, fewer fields, insert data. This is really a data warehouse capability that's now available directly on the data lake via, really Lakehouse architectures with Arctic and Iceberg. So we have these two tables loaded. We have the new data loaded into sales and customer. We've merged. But now what we really want to do is we have the new data, but we don't necessarily know if the new data is ready if it's fit for consumption broadly within the business, right? So what we want to do is some data quality checks. So the first data quality check that we'll do is actually a referential integrity check. So basically what this is going to go do is look at the sales table, and it's going to go look and see how many records are in the sales fact table. Then what it'll do is it actually go take a look as I execute this, it actually go take a look and say, okay, now look at the fact table, but also join it with the customer dimension table and the product dimension table so we can get the lookups for these fields of these foreign key relationships within the fact table. And so what this will basically show us is that, hey, if I load this fact table, well, if you have mismatches and you're missing some keys somewhere else, that can actually produce wrong results and misleading results downstream. And we want to avoid that. And that's why we really leverage referential integrity, which you can see here came back just fine, which is great. And this is, again, really a data warehousing capability that's now possible on the Lakehouse, right, of being able to make sure this check passes before we expose any data to users. So we checked referential integrity. The next thing that we want to check is actually we have some business rules around what the values should be. So sale ID should never be negative. Product quantity should also never be negative. So what we're going to go ahead and do is just see how many bad records there are in this new fact table that we just loaded, or really the new data within there. We can see sale IDs, we're looking good, we have 0 bad records. But we do have 4 records that actually have a bad product quantity. So at this point, usually, from my background, I'm sure a lot of people in the audiences, you start panicking at this point, right? You have bad data in there that's wrong, and it's traditionally, it's going to go affect all your downstream systems because it's just in the data set. But with Arctic, what we're really able to do is isolate those changes. So even though we've made a bunch of changes to 2 tables, none of these changes have been promoted. None of these changes are available to anyone downstream because they shouldn't see them yet, right? So if we go actually look the same quality check against the normal sales table, and you'll see I'm not putting an @ sign, I'm not referencing a branch here, so it's going to implicitly go to main, which is implicitly the branch that everyone else is running on, right? All your dashboards, all your reports, all your ad hoc analysis, and you can see here that we still have 0 bad product quantities. So any of the issues are not actually in prod yet. So at this point, we can kind of take a deep breath, right? We don't need to necessarily panic as much, and we can actually kind of go with a clear head at, all right, how do we go ahead and solve this? We don't need to make any rash decisions or really hurry to potentially make a mistake. So let's go ahead and investigate what the problems with this data are. So we can go ahead and look at all the records in this new data that we've loaded where we have this product quality problem. We can see here that we have 4 records here. It's in about the 2-minute mark. It's in about 25 seconds. We could certainly go ahead and just delete these records if we wanted to by the ID. But let's just make sure, and really we can do it by the timestamp too. Let's make sure that, again, because we don't need to make any rash decisions, we don't need to rush. We can actually go ahead and take a look at the surrounding records, right? Let's just make sure that there's not some weird anomaly that's happening around there that's only coming through there. We can see, sure enough, yep, product quantities all look good. Here, there's not even any that are 0. Looks like that something upstream, maybe application or the database or the transfer may have had a problem with this data. So we have options here, right? We can go ahead and go look at the application, go look at the database, go look at any of these aspects to investigate it. Meanwhile, our users aren't seeing anything bad, right? They aren't seeing the quality problems. So this gives us freedom. Right? It gives us the ability to make conscious decisions that's really the right ones that we want to make. So here, what we want to go ahead and do is, again, we can choose to mitigate this in a lot of ways. But for what we want to do is we want to go ahead and actually delete all of the records for the whole 19th hour. Right? We don't want to just delete 4 records in the 25th, around that 25-second mark. We want to go ahead and delete the whole hour so that people can see the gap. And so what we see here is that we're going to go ahead and run this delete statement from this sales table on this branch, and specifically delete between 19 zeros and 1959.59. So same thing, similar to the merge before, the update before, Spark's actually going to go ahead and reach out to Arctic, gather the data from Iceberg, and then actually go ahead and delete individual rows from the data files that we've actually written. Right. So again, this is a capability that's generally reserved for relational systems or really data warehouses. And this is something that's, again, that all of this is happening directly on S3, right, using open formats. So now let's just go ahead and run this, this query again to just kind of confirm that we don't have any quality problems. OK, things look good, right? Now we can be confident that we're ready to promote these changes to production. Right. And again, the changes that we made were really we inserted into one table, we updated another table, right? So we're already working with two tables. We checked the data quality, we deleted some records, and no one downstream, reports, dashboards, ad hoc, saw any of these changes yet. So now what we're ready to do, though, is expose these changes to them. So we're going to go ahead and run a merge branch, and we're going to say the branch that we've been working on, merge that into main in the Arctic instance. So we go ahead and run that, and sure enough, right there, we've basically we've promoted those changes into prod. So what we can do to confirm that is really look at this statement here, and basically what this will just go ahead and do is look at the number of sales records per hour, right? And sure enough, we can see here that the latest hour that we have is actually 18, so we actually don't have the 19th hour as we expected, as we wanted, right? But so this whole time we've been writing with Spark and reading with Spark, but all of these changes that we've made are also visible to any other engine. So we can actually go in here in Dremio, and that query that we just ran, we can actually go ahead and run the exact same query in Dremio, right? So run the same exact thing. We can go look at the values here, right? So if the 18, it was 14 sales records, 11, 8, about there. We can come back to Dremio, we can see, yeah, 14, 11, 8, and we don't have the 19th hour, right? So these changes are visible to everyone, readable and writable to everyone. So let's actually go ahead and do something with this data now, right? Like we've been really updating it and inserting data, but now let's kind of take it from a consumer's perspective, right? What can they now see? So if we pull up this business space here, we can see we have a few tables, including this one table, or this is a view, this is all virtual, where it basically denormalizes. It says, hey, let's pull the sales fact table and this customer dimension table and the product dimension table into one view. Let's join them similar to what we did in Spark, right, for the referential integrity check. So here we can see the preview of the data, right? We can see customer, we can see product. So we want to go ahead and actually open this up in Tableau. So we click the Tableau button here for this data set. We go ahead and select the Tableau, the file that we've downloaded, which is really just pointer files, not downloading any data. Tableau will open and recognize that we're actually configured for single sign-on to Dremio Cloud. So I'm going to go ahead and put in my email address here, and then I'm going to go ahead and log in to Dremio Cloud using my normal G Suite credentials. And here you can see that, yep, okay, we logged in, and now you can go ahead and close the window. So great, we'll go ahead and close that. We'll go back over to Tableau, and here is the data set all pulled up. Right. So the main issue that we were having was really with product quantity. Right. So let's go ahead and actually pull product quantity into the shelf here. And what we can see is that it'll actually default to sum. And when we actually execute this, what we want to do is actually default this to average. Right. We want to actually look at the average. And what we actually want to do is look at a specific range of dates, right? Like, let's just look at the last week or so, maybe let's look at maybe 2 weeks, right? I think that's actually 3 weeks. Just to make sure that we can actually see visually what the, and here it'll default to year, but we actually see the data that we inserted, right? The new data that was not there before. And here we can see, sure enough, March 1st, right? We can see that the average product quantity kind of changed a little bit, but it's basically on track with the trend, right? Now, keep in mind that had we not done all of the quality checks, had we not been leveraging Arctic, had we not been doing these kinds of things, this data point, if I was looking at this as a business user, this would be way down here, right? Which I would panic about, right? It would immediately be causing fires and escalations, and hey, like what's wrong here? Like, why is this happening? And can we reverse it, right? So that's where you start to think about those kinds of things. So with that, really what we've shown here is really around the open lakehouse architecture, and really how we can leverage things like branches and tags, and really the open lakehouse architecture, where every engine is really a first-class citizen, right, around Spark and Sonar and Hive and Flink and engines like that, to really enable this fully open lakehouse vision, leveraging these technologies.